The following content has been provided by RWTH Aachen University.
Welcome everybody to part 2 of SwiftUI. We did cover the basics yesterday on how SwiftUI is different from UIKit on a more fundamental level. I talked you through a couple of the architectural differences, but we haven't really seen how to compose any sort of bigger user interfaces. We played a little with the VStack to put things beneath each other, but that was pretty much it. So how do you get more than one view on a screen? We're going to talk about a few layout views. This is not a complete review of what's out there. That would be pretty boring, right? So rather do that yourself. Look at the documentation or any of the many resources out there. I'll point you to a few that I like personally if you want to catch up on this. This is also a moving target, right? New kinds of views occasionally come out and expand what SwiftUI can do. So we're just going to look at how layout views work fundamentally, and you'll see, the basic recipe on how they're being used. So layout views. There's one fundamental difference in layout views, which is that some of them will actually tend to pull in, so they basically shrink to just include what's inside them, whereas others will tend to push out, so they will try to basically grab all the available space around them. It's useful to know how each view behaves. I mean, you can also just try it really quickly with the preview function, and on the canvas it's an easy test to see how it behaves. But it's a useful distinction nevertheless, and if you want to find out more about that, there is a nice book by Mark Meukens. I'll give you the link at the end of the talk. That actually has a nice sort of markup saying which view behaves which way. Now, first of all, you've seen VStack, and of course there's another one, which is the HStack, to put stuff next to each other, and there's a third one that puts stuff in front of each other. And so very simply, these are all pull-in container views. So according to that definition I just gave you, they will shrink to just basically contain the stuff that's inside them. And like all layout views, so layout views are the container views in SwiftUI, right? Like all these layout views, they can only have 10 child views. We discussed that yesterday. If you want to have more, the easiest way to do that without any effect on the user interface is to group things, because that will break down this sort of 10 argument limit for you. Here's basically the code that created these three things, right? So we've got, here we have the VStack example. So we're simply giving it, we're taking the VStack, we're aligning .center, which is the default, so you could actually leave that out too. And we give it a spacing of 5 so that these things aren't mashed together completely. And then we basically just added 3 text views as children, right? And since it's a VStack, they're aligned beneath each other. First one is blue, second one is green, second one is orange, and each of them is half of the width of the one before. Now, if you just change one letter in this code, make this an H stack, you get this. If you make this a Z stack, you get this, right? Where the blue one is at the back, and then the green one is in front of that, and the orange one is all the way at the front. There are sort of sibling views of these, which are a little more recent, called lazy VStack and lazy HStack, which only load things when they're visible. This is probably something you've already seen in UIKit with cell behavior. That is mostly there for performance reasons. This becomes really interesting if you have long lists that you're scrolling through, that the user's scrolling through, and you don't want to load everything at the beginning to avoid sort of a holdup of your UI. All right, so the next one I want you to take a look at is list. List is for vertically scrolling content. The way Apple defines it, it's a container that presents rows of data arranged in a single column, optionally providing the ability to select one or more members. That's a short definition of this. So selection is a thing here. So you might have the option, if you wanted to, you can turn that on to let users select one or more of these rows. It's mostly for simple content, very efficient to put stuff in a list. As you can also see, it aligns things in a more simpler sort of left-aligned way by default. And the items don't all have to be the same type. Right here, I put 3 text views in the list. So it's a static list of 3 items that are all the same type, but they don't have to be. Right? As long as they're views, you can put them in there. So you can put a text view and a picture and so on. You can also enable delete via swipe. So if you wanted to make this list editable, you could add a function that's a simple modifier that says that you want this to be deletable, and then people could do the delete gesture on each item. Again, the grouping trick is available, but there's another option, which is section. So if you actually want to separate your group, because maybe you have different sections with different topics here, you can do that, and it could even include a title. We'll see that on the next page, because list has a sibling that is called form, and it's very similar in what it looks like. In fact, on iOS, they both use a UI table view with pretty much the same parameters as the underlying view to actually finally render the thing. So the difference here is more in the semantics, like what Apple wants you to use these for. Why is this interesting? Because remember, these views are available on iOS, watchOS, iPadOS, macOS. And on different platforms, a form might actually look different, very different from a list. On iOS, a form is pretty much a list, right? Here's an example of form. So you just change this into say form, and then you give it its children. Here, the children are 2 sections, and each of these sections in turn has this one has 2 groups, and this one has just individual items. Form looks on an iPhone just like list. You may recognize this actually if you open your settings app on the iPhone that is using precisely that format. And what Apple says is that a form in general in SwiftUI is meant to be used as a container for grouping, how do they put this, controls used for data entry, such as in settings or inspectors. That's Apple's speak here. So as you can see, you may want to take a look at the documentation and pick the right user interface component based on the semantics of what it's supposed to be used for, because you don't know how it's going to be implemented on each platform. So if you see it on iOS and you think, oh, it's just a list, I'm just going to use a list, then it may end up looking very different from what you intended on macOS, because what you really wanted is a forms interface. See, so you want to give your intention, your semantic intention to the UI kit, so that SwiftUI can then pick the right visualization of that on each platform that's being supported. This also illustrates the group use here to break down the 10 items barrier, and it shows that sections can actually have a title. You don't need to set it, but you can, and then that gets rendered here in all caps in this gray on iOS again. What you may end up working with occasionally when you need to position things on the screen is spacers. So spacers are basically elastic, extensible distance creators between items. And if you have a couple of them in your interface, a couple, for example, of vertical spaces, they will distribute the available space between them equally. But you can also give them a target width. So for example, here, this is a content view. As you can see, we're just giving you the basic content view at this point. Right? We're leaving out the import and the preview stuff, because it's all boilerplate code that you're not going to be editing for these simple examples. So here's an H stack that has a spacer and a V stack, and then it has another spacer and another V stack and another spacer. So this is the stuff we're seeing here being arranged. And you can also see modifiers in use here, like the text is being extended with the font and with bold. This one also. But what's interesting is how these spacers divide up their space. Right? So this is the first spacer that's being used here. This is the second one. This has a minimum length of 150 pixels, or pixels in the iOS sense. And then we have the last one here. So as you can see, apart from this one demanding at least 150, these two divided up their space equally between them. Layers are another way to put stuff on top and behind views. So rather than Z-stack, you can also use layers, and they allow you to do interesting things. For example, if we have a content view that has an image in there with pigeons here, and then we give a couple modifiers. For example, we want this to use the maximum width of the device so that the image looks nicely, without any borders. That's a very common immersive view of media on the iPhone. We want limited opacity, so make it a little bit less than fully solid. And we might want a little bit of a background layer behind that image, right? So as you may remember from last time, background is actually not just setting a color, it's actually a separate layer. So that's how this picture gets this red tint, right? And now, another one behind the red is a yellow one, and we can put another one behind this with a blue, with a blue color. And now we create an overlay over this image, and that overlay has the text pigeons in it with a foreground color of white and a large title font, and that's pretty much it, right? So what you can see here is then that this text got layered on top of the image, and we're actually using these backgrounds, which also create layers. We just don't need to call them layers explicitly, to create this nice sort of blending effect of multiple layers in a view. All right, so that's one way to use instead of this very sort of drastic Z-stack fully opaque model. Now, I don't want to go into more about like how you can the various ways of layout views that are out there. There's grids, and there are all kinds of ways to arrange stuff on a single screen. But what I want to use a bit more is to talk about two other topics. One is how, if you get to larger and larger applications, the model view model metaphor becomes more important. And then we'll talk a little bit about actual navigation and passing data between your views and your content. So a few words about MVVM. Now, we've talked about MVC. This was something that you probably knew already, but we reviewed it quickly when we started with UIKit. And MVC has a couple of big advantages, right? So model view controller, it's pretty clear what goes where. Your model code, anything that stores data goes into the model. Anything that gets rendered on screen goes into the view. And kind of everything else goes into the controller. The official idea, of course, of the controller was just to say it's going to basically tell the view, and it's going to link the view and the model together, at least in Apple speak. That's kind of the model that you've seen Apple adopting, right, where the controller sits in the middle. That's why for every view that you have in UIKit, there is a view controller, right? The view controller is sort of your go-to place for managing how your model influences your view, right? So whenever changes something in the model, you want to make sure your view gets updated, and usually that's a task that the view controller needs to do. MVC is incredibly widely adopted, and the data flow between the different models in MVC is pretty clear. At least you can sort of agree on a way that this works. If you have, let's say, a team of developers, you can say this is how we use MVC. Or if you have a framework like UIKit, there's a fairly clear idea on how that works. Problems, I already hinted at them yesterday, is that people tend to put pretty much everything into their view controller because it's such a convenient place, because you have access to everything, right? In the view controller, you can access the view, you can access your model, and it's fairly convenient to just grow your view controllers out of proportion. If you look at your own code, you may find that your view controllers are tending to become pretty large. There are a couple ways to address this, to pull code out of view controllers. For example, networking code doesn't really belong in a view controller, right? It should be its own separate thing. But there is this tendency. The other problem is that view controllers are hard to test because you need to drive a user interface basically in order to test the view controller because it's directly linked to your views. So in 2004, a British software developer came up with the idea, Martin Fowler, to sort of change the MVC concept a little. He said, well, what we really want is we want to pull a few things out of the view, which is, oftentimes the view is very specific, should be specific to a device, let's say a screen, etc. But there are lots of other things that need to happen to take the model data and make it ready for the view to display. For example, maybe the view needs an integer number and the model only has a float, right? So it needs to be truncated, for example. And these kinds of things are not they are not visible on screen, but they are necessary for the view to do its job. And so Fowler suggested, wouldn't it be nice if we could instead have what he called a view model? So it's sort of a separate part of your model, but it's about preparing things so that it is ready for the view to display. And of course the other direction too, right? The view does something, somebody enters something, maybe you need to do some sanity checking on some numbers that are being entered before you actually pass them on to the model. That could also be inside the view model. Like somebody shouldn't be entering, I don't know, letters when they're supposed to enter a phone number. And so he said this could be a role of the view model, like the separate third entity between model and view. And then he said you could actually basically architect your application so that the view is no longer necessary to actively drive the view to be updated whenever the model changes, which is typically the role of your view controller, but you should be able to just link the view and the model together in a way that the view automatically represents the state of the model at any time. How do you do that? Well, you would have to normally write tons of glue code, right? Any variable in your model changes, you would have to go through the view model to interpret that change and then basically make sure that your view actually has that updated information. You don't want to write all that glue code. And so adopting MVVM in UIKit is actually pretty hard because you would have to either write all that glue code or use a third-party framework that creates that glue code for you. Why is that the case? Because UIKit never inherited one thing from macOS 10 that it probably should have inherited, which is bindings. In 2003, macOS 10 introduced Cocoa bindings. And I remember giving the class on macOS 10 here in this room, and I was like super excited when this was going on, right? When we first saw Cocoa bindings. The cool thing was that you could all of a sudden, you could say, here's my code, here's my variable in the code, here's my UI element, and I'm not just saying, this should be controlling that, but I'm actually creating a two-way connection between the two. Like I'm fully done. I'm just telling it visually, even in a graphical editor, this variable is what should be represented in this view, and maybe there's some kind of translation that needs to be happening between the two, but they are linked, right? They are bound together. And if the text field, for example, if a number gets edited or a string gets edited in text field, that should directly update this variable in code. I don't, back then with Cocoa bindings, this was awesome because it meant you didn't have to write all that glue code that said, oh, if the text field returns a new text string, then write that into that variable in my model code, right? This was no longer necessary. And iOS never inherited Cocoa bindings from macOS 10. Partly, maybe they were too expensive. Also, the implementation of Cocoa bindings in macOS 10 wasn't maybe the greatest that you could do. It was using key value observing, and it was, as people say, it wasn't strongly typed, it was stringly typed. So basically you were just creating strings and you were really hoping that you didn't make any typing mistakes because you basically were typing in as strings what you were looking for. And as we know from enums, right, in Swift, enumerations are a much safer way to ensure that something is one of a small list of options rather than using strings to identify keys and values. So anyway, and now Microsoft enters the scene. Microsoft creates their new Windows Presentation Foundation in 2005, WPF, which you've probably heard of. And they said, we're going to put these things together. We're going to use the idea, Fowler's idea of the presentation model, but we're also going to use the idea of bindings, of automatically generated bindings, actually, right? So, and that combination, this architecture, they dubbed this MVVM, so model, view, view model. This is where the name is coming from. And today for SwiftUI, this is your natural choice to do it this way. Why? Because SwiftUI is already based on this idea that your views are always a representation of your model. In fact, your views, if you write a clean SwiftUI app, have no state, right? Anytime a view is asked to render itself, it is computed. Remember, it's a computed property, right? The body var is a computed property, so there is no state in the view. It has to go back to the model and create itself afresh. And that's cheap because, structs and stuff. Now, this has a couple of other advantages. If you use MVVM in this way, it also gives you a nice way to test your code, because all of a sudden, you now have your views, your SwiftUI views, which of course is user interface code. You've got your model code, and for the most part, in between, in theory, you have your view model, right, which is a separate part of a model that is there to translate between the two. And in many cases, this is very simple. Maybe you don't need to do anything. If a user is just basically clicking on an up and down arrow to adjust a number, and you don't care about any bounds of upper and lower bounds, then your view model doesn't need to do anything, right? It could directly move the data from one to the other. So your view model could be nearly empty, but with larger applications, your view model is going to get more substantial, right? This code you need to adopt the two between the two. But the testability, your view model, is then something that you can actually test without having to drive it from the user interface, right? It could actually be driven from test code, which is convenient. And your views become smaller because your views no longer have to do all this interpretation and mapping themselves. So that's the idea behind using MVVM. Now, I will say, if any of the code that we are doing here, the examples, it doesn't make sense to have a separate sort of file that is view model code, right? It would be overkill. In fact, the inventor of MVVM, the Microsoft engineer, said, MVVM is overkill for small projects. But once things get to a certain size, it really makes sense to pull out this functionality to keep complexity under control. So this is what it looks like in MVVM. You've got your view, which is bound with two-way, in both ways, or two-way bindings in a way, to the view model. The view model then interprets what's in the model to send to the view, right? Or it gets changes from the view and passes these on after interpreting them and translating them to update the model. And the model is basically there to, like normally, store your data. So your views become somewhat more active, right? They're also there to change things, right? Because where else would changes from to your model come from? They would originate in the view where the user enters something. But other than that, the view model is sort of the centerpiece here, and in many parts for small code examples, it actually doesn't have to do a lot. In a way, what you get with SwiftUI, if you build small starting projects, you basically have a view, you have model code, and the things are tied together by SwiftUI pretty much for free for you. So MVC has sort of a sibling in this way, MVVM, and it's an improvement over MVC in many respects, especially if you do declarative programming. All right, so the other thing I wanted to say, because we've always hinted at this, is that of course SwiftUI has a cross-platform mindset. Now, it's not cross-platform in the sense that Java, for example, is cross-platform, that you basically run one and the same binary code on the same virtual machine on various platforms or something like this. It's also not cross-platform in the sense that it can run on Windows and Mac OS and Linux, but it is cross-platform in the sense that it can target different device classes in Apple's ecosystem. So apart from iOS, it can also target iPadOS, Mac OS even, and watchOS. So here's an example of what SwiftUI lets you do. So you can write some code. This is taken from an Apple example where they have an app that lets you I don't know, configure your favorite sandwich, I think. And so you can see on iOS it looks like this, right? It's got your title of the current recipe you're looking at. You specify some bread spread and whatnot, and you've got toggle buttons for including salt or not and stuff like this, and you've got a quantity setter, and you can press order if you're done. And you can, as you can see here on watchOS, this SwiftUI model would basically turn the selection of including salt and including red pepper, this section here of this larger dialog, would actually turn into its own screen, right? Because these things would not all fit reasonably onto a single watch face. On the other hand, on a Mac, this is what it can look like, right? So as you can see here, the include salt and add red pepper basically became checkboxes, right? Because that is the way that you expect something like this to look on a desktop application. Also, the quantity is something you can enter directly and adjust with these things rather than having minus and plus buttons, touch buttons, as you would expect on a smartphone. So the look is different, and behind the scenes, actually, SwiftUI uses things like UIKit to render stuff ultimately. But it does take care of this part of this translation that you're doing here. Now, you still may have to do some of that work yourself, right? You may still have to pick, there are some views that are not available. For example, I mean, the digital crown that you can use on the watch doesn't exist on a smartphone or on a desktop, so there isn't much to translate that to, right? But for a lot of the standard user interface components, there are reasonable mappings to the watchOS interface, to the iOS interface, and to the Mac interface. I really encourage you to try this out, right? You launch Xcode, select multi-platform, and build a super simple Hello World app in SwiftUI, and then see, by changing the target, what it looks like, you know, in the simulator on iOS, on iPadOS, on macOS. So if we compare this to what we've been doing with UIKit before, we can see the following, right? So UIKit gave you view and controller were basically provided, view mostly by UIKit. Controllers, your view controllers were usually things that you would subclass, and that's a lot of where your custom code goes. And your model is being supported by things from Foundation and Core Data. If you're lucky, you can use Core Data for your data storage. And so if you then wanted to move something to macOS, for example, you could probably take over the Core Data model that you had. You could probably take over the Foundation stuff, because that is actually similar between iOS and macOS. But these two parts, you basically had to build anew, right? You had to use AppKit instead of UIKit, write new code with this, and your controller classes also using AppKit and having lots of custom code would also be coded fresh. So the difference here, doing this in SwiftUI, is that you can actually reuse much more of your code, right? So SwiftUI, your user interface commands, there is a form interface on iOS, and you can use the same form interface in your SwiftUI code on macOS. Of course, you still need to run it on each platform and see whether it looks okay, whether you need to tweak anything. But that's sort of a big leg up to get stuff running on the desktop, for example. Now, if you're coming from UIKit, and you all are, right? You're taking this class. Here's a list. You don't need to learn this by heart, but I just wanted to point it out because one way to approach learning SwiftUI is to think about, okay, if I know my UIKit classes, my views that are available in UIKit, how do these map to SwiftUI, right? So you can see, for example, that we talked about the list view in SwiftUI, and that is actually backed by the UI table view, right? Form is the same, as I said. We haven't listed it here. But you've got, for example, a simple text that's being displayed in SwiftUI is actually what you know as UI label, right? Whereas in some cases, in almost, I would say, maybe the majority of cases, you could assume that the name is just dropping the UI prefix, right? So UI stepper turns into stepper, UI date picker turns into date picker, UI button turns into button, etc. Right? So a lot of these things are named in a way that you will recognize them from UIKit. If you don't recognize them, then this may be a useful list to take a peek at. All right. Now, and SwiftUI, of course, has new views, right? For example, ZStack didn't exist, right, in UIKit. Now let's take a look at how we actually handle data being entered, having to change in your view in SwiftUI. Here's a very simple example. We have a content view that has a button that you can tap, and it has a number. Right? That is the number of times the button has been tapped. And this is how we would expect that code to look. Right? There's a struct, the content view. It has a variable. Tap count, it's a var, so we can change it. And here's the body var that gives us a vstack with some spaces just for, to make it look nice. It says tap count with a large title font, has another spacer, and then the button tap here. And the button has nothing in there right now, because this is where we would basically assume in the button, in its action, where we can change the value of the current number of pressed items. And this code so far is fine, right? It would do this, and the button right now wouldn't do anything, right? It's inactive. It's not doing anything because there is no code being executed. This is, by the way, since we haven't introduced it yet, this is how you create a button, right? You say button, you say what it's supposed to say, and then again we have this closure, this trailing closure, which has a piece of code that is executed when the button is being pressed, right? That's how buttons work in SwiftUI. Now the problem is, if you try to do this, this is just showing a variable, but if you want to change that variable, it gets a little trickier. And we'll get to that later, how we actually make it so that the button will be able to change that variable. For now, let's take a look at how we can handle things like, for example, a number of things to put in the list, right? So here we have a let constant, a couple of names in an array, and our stack here just fills in text items with each of these people, right? So it steps through the array we have up there with a for each loop and creates an index variable that lets me then access each individual item in the list. This is very, very simple. We're using an index here, but we can actually do better. We don't actually need an index variable. We can also get rid of the index variable and just say, instead of introducing and then counting through an index variable, just use a reference back to each individual item in the array. So we're passing in here for each people in iOS id \self, and this basically means that we get get this item and then this item and then this item returned, and we can use that immediately as the variable person, and then we just pass that on the string into the text view. Now this works because what SwiftUI needs, if it's asked to step through this array, is it needs to basically be able to identify every single view on the screen uniquely, right? Because when things change, it needs to be able to detect where is this thing that I'm supposed to update. Here we just have an array of basic strings, so what's unique about each string is simply what's inside each string. So we can use each string in our array as an ID because all the strings are different from each other. This wouldn't work if we had two strings with the same content, then this would not be a proper ID. But here we can work with this simple trick. If that's not working, then often what you will see is that people introduce something called UUID, which is basically just generating a monstrous unique identifier, a long number basically, and that is being used to attach as an object, as a property to each element, and then you have unique IDs for each object that way. Now, let's do a little bit of customization. We just saw a loop going through and generating 3 different items, and once you get to that, what you often will see is that people try to start reducing the size of their view code, right? So the view shouldn't become too massive, because otherwise, as you know, the code gets hard to verify. So what you can do is you can pull out things. You want to pull out, when you have a complex view, you want to pull out smaller parts so that you can actually handle your code a little better, right? So we'll show you an example of how that can be done. Here's code where we are putting a check mark in front of each name, right? We could have done that in the content view, right? It would have just grown the computed body var code a little more. But we've decided to pull it out instead and created a new view. Right? This is a view. It's protocol-oriented programming, so it's following the view protocol. And we call it custom row. It's our definition of what a row with a check mark and some text behind it looks like. Okay. It's kind of like introducing a new widget in UIKit if you want. And it's very simple, right? All it needs, obviously, is the string that's supposed to display after the check mark, and then its computed body variable will say, all right, I'll return you an H stack with the check mark image, and then the text that you gave me in a large title font, and then I'll add a little padding, and I'm done. Right? So that's a custom view that we've created here called custom row that won't render itself automatically. It will need to be called from somewhere else, right? With a proper string passed in, a name passed in each time. And that's exactly what's happening in our main view here, the content view itself, because it's basically saying, well, I'm using a lazy VStack here, and the for each loop now actually says for each of these people that are in this array, please use the string to create a custom row with that name. So that creates custom row views that we've defined down here. And as you can see from this, this is a way to break down your code into manageable portions so that you can keep better control over what's going on. All right, so this is sort of the key trick to modularize your code, even if you're still inside a single file. And if you find that these things become more than 1 or 2 pages of text, just pull this out into a separate file, right? Make it custom row .swift or custom row view.swift, something like that, and it will become its own file, and you can import it from the other end, and you get nice modularization of your code. So in a medium-sized project, you may end up with .swift files for each of your views that you have in your that you've defined in your code, in your application. Now, the next thing I want to move on to is how we can actually change things when the user interacts with our user interface, right? So we've now been able to assemble a bunch of stuff on the screen in various ways with different kinds of layouts, and we want to actually be able to, of course, react to user input, right? To feed that back into our code. So how do you do that in SwiftUI? It's actually pretty elegant. Here's our same example again from before, where we now are actually going to change variables. So this is the same stuff that we did before, and I inserted some code here that says increase tab count by 1, right? That's how you would expect this to work, right? Because I've got a button, the button has something that it will do to this variable. It's a variable, so I can change it. And this should be fine, shouldn't it? Well, it actually won't work. This part will not compile. Does anybody have an idea why? Yeah.
Because our views does a struct that gets thrown away every time we render the view, so tab count will always be sort of initialized as 0.
Mm-hmm.
And when we increment the tab count, nothing much happens.
That's right.
Even because it's not mutating, we aren't even allowed.
Yeah. So in this case, if you did that, first of all, structs. If you have something inside a struct, if you have code that wants to modify something inside a struct, like a property inside a struct, remember it needs to be mutating, right? So we would actually have to tell it that it's mutating. And the problem is on computed properties you can't actually apply mutating. But you're right. The reasoning behind all these limitations is that structs are lightweight. Structs are being thrown away all the time. So it's not much use changing a struct and then throwing it away, right? So this is just the wrong way to think about it, okay? But what you can do, and this is where it becomes, well, a bit tricky maybe, and something that you really need to get used to. If you want to store state, and we are now storing state inside a view, which should make you a bit nervous, right? Because that's not the pure religion of SwiftUI, but sometimes there is a need to store some user-specific state. Let's say, for example, you've got a user interface in which you can unfold or hide certain parts of a list, right? So like sublists with the little triangle, you can show and hide them. And whenever you show them, maybe you want to, I don't know, play some background sound while this subview is being shown. Maybe it's an album cover, and when you close it again, you want that background sound to stop, right? Let's assume that it's what you do. So you need sometimes to know what state your user interface is in to directly influence your UI. So sometimes there are cases where it's interesting to actually have a way to access some state inside your view. And the way that we do this is with a so-called property wrapper. So property wrappers are things that look like this. They have an @ sign and then a particular keyword that is unique to Swift and SwiftUI here. So this is the change you need to do. You need to add @state to this definition of the variable. What does that do? Well, it says, SwiftUI says, well, I know that this view will get thrown away, the struct will get thrown away all the time, but obviously the developer wants to keep some data around, even when the struct gets recreated. So SwiftUI will reserve some space in somewhere where it is not being thrown away each time the view is destroyed. And that way, this variable, this state variable, basically creates some state in the user interface and remains available and gets updated with the tab count. So this code will compile. Why does it say private? Because you are supposed to use @state only for things that you need to hold on to as state inside a single view. Right? So that's why Apple recommends you declare it also as private. You don't have to, but it's recommended just to make it clear to yourself, to the compiler, and anybody else that this stuff will not get used anywhere else. All right, so with this wrapper, what it basically does, it lets you modify simple properties stored inside a single view. Private is recommended. And when you change any of these properties, it will re-invoke the computed body, right? So the view will render itself fresh when this variable gets changed. Yeah, and I just, for reading through these slides later, I mentioned here that the button's action is this trailing closure that we already discussed. Now this is great. So now we know for these simple things how to hold on to something that the user does in the user interface component, and that action can actually feed back into code. But we may actually need to go both ways. And for that, we have two-way bindings. So here's an example. Again, we have a very simple content view here that just creates a form with a text field and a normal text label and a text field. Now, a text field is something where you can actually enter text, edit it. So it doesn't just have a prompt, but it also has a text variable. And that text variable is the one that the text gets written into once the text field is complete. Now, with this, you need to use a $sign in front of the variable name here, because that turns this property, it's still a state property as we can see here, but that turns it into a two-way binding property, meaning that the text field view will display the current value of the name property, and anytime it changes, it will update. But also, it can actually change it. So when the user enters stuff in there and the text field gets a new number, it can actually update this variable. So two-way bindings are important to be able to actually access things. So this is the key thing here about this slide, that you need to set this, do this with a $binding so that you can actually get to the changes that happen from the user input side and also from the code into the UI. All right, so this is the most frequent property wrapper that you're probably going to be seeing, this @state. There's another one that you will probably see frequently, which addresses the problem of going across a single view, right? So far, we've only done something inside a single view, right? If you want to move outside of that view and have something that can influence another view, you need a little bit more. So let's take this example of a media player here. And this media player usually shows the word silence, and it has a play button. When I hit the play button, the cover appears, the music starts playing, the subtitle appears, and the button changes to say you can pause to, again, enjoy the silence, right? And what we're going to be using in here, this down here, this play or enjoy the silencing, is a custom media control view that you will see a definition of. It's very simple. And in order to get the information across these views, we will need bindings. So here's the code that I will go through real quick here. So we have a variable here that says, private var is playing equals false. It's a state variable, so that looks good. We got our view itself. It's a spacer, and then it actually decides. Maybe this is also interesting to see. The view will actually return something different based on the state of the program, right? It will say, if is playing is currently true, then I'll show the image and I'll show the photo. But if it is not true, then I will show the text silence instead, right? And below that, either way, whether I'm in the if or the else clause here, I will show the custom media control. And so that the custom media control knows what it needs to display. It also needs to know whether we're looking at, that it's supposed to be playing or pausing. It actually needs to get passed in this variable, right, as an argument. The problem is with this code, that's not going to work. And again, the reason for that is simply that if we do inside the custom media control, we say, well, what's currently going on? Is the playing variable, is it true? Then I will show the pause button. If it's false, I will show the play button. And similarly, I will show a different text based on whether it is playing is true, then it will say enjoy the silence, or if it's false, then the text should say play beneath this thing, right? That looks great, but it's not going to work because we've only used a simple state variable. And as we just discussed before, the state variables will only be true inside this view, right? So this does not actually help to pass the stuff from outside the view into the custom media control. So instead, what we need to do is that we need to change this to say at binding. At binding then means that inside this custom media control, we actually get the value passed in that is currently living inside our parent view, right? So the parent view, that is our whole player, has a current idea of whether this is playing is currently true or false, and that is our ground truth that we want to access, that we want to share with the custom media control view. So this is how you can do that with the at binding instead of at state. So that's when you need to link things across different views. There are a whole bunch of other property wrappers, and this is actually some of them are fairly advanced material, and they will take a little bit of wrapping your head around them. When you come across them, you will find out what they do. I won't go into too much detail here. There's state object, which is a property wrapper that essentially instantiates an observable object. There's the observed object property wrapper that subscribes to one of those observable objects and invalidates the view whenever that object changes. So you can see how the fundamentals of MVVM are being made available to you here through these property wrappers. And there's environment object, which is a property wrapper for an observable object that is supplied by some kind of parent or ancestor view, and at environment, which is one actually that we're going to get back to when we get to navigation. And that's the property wrapper that lets you read a value from a so-called environment of a view. You can imagine that a little bit like sort of the a global data storage for things that are true for an application as a whole. There are even more property wrappers, but this one is one that we will see again when we talk about navigation next. Also, I talked about MVVM before, and that these things help you to get towards MVVM. You will probably not really see the term MVVM used by Apple a lot, simply because Microsoft invented the term, so Apple's like, I'm not going to use that name. But anyway, let's talk navigation. So we're still mostly, we haven't really left our screen, right? We're still on one screen. We've shown different things on our screen. We've seen how we can change stuff. When I press a button, I can display something else. But what if you actually want to do a typical drill down app, right? You've got your mail, your notes, anything you're doing is all going to be typical drill down apps, right? Your utility apps are often drill down applications where you have an overview and you tap on something and that gets you into your detail view. Now, so the first example I want to show you is this. So let's say you have a home screen that has an offer to tell you a secret, and the user can then either say, sure, I want to hear about that secret, or they're like, I'm not really interested. Okay. You also see two little buttons up here in the right that have additional information on that sort of starting screen of this drill down menu. Now, if I press sure, let's say I want to actually get to the secret, right? So the title gets replaced with the secret, and the secret, of course, is that SwiftUI is awesome. And I can go back from here automatically, by hitting that little back arrow. Or if the user says, I'm not really interested, then you get a different title in your target destination view here. It says then, okay, so don't, and maybe you want to have a button that can take you back to here. Notice that this one doesn't have the automatic return. Right? So we did this just so that you will see two different ways of navigating back and forth. This is the standard way, where you have this little back button automatically generated for you, and this is a custom way where you don't have that back button. Sometimes your user interface, it just makes sense not to have that navigation. It depends on the semantics of your app. Also, this is fresh and hot off the press, right? This is iOS 16 specific because what you're going to be using for this is called navigation stack. Until iOS 16 came around, this thing was called navigation view. And navigation view actually just months or weeks ago got soft deprecated by Apple and is now called navigation stack. But the simple use cases are pretty much the same. The replacement of navigation view by navigation stack is mostly because it also supports some more powerful jumping across in like navigation history, popping all the way out from a deep drill down view to, let's say, the home screen of an app or something like this. So here's how you use navigation stack, which used to be called navigation view. We have our starting screen, let's call it, right? The home screen maybe of our app here. And it is this VStack that has the let me tell you a secret and the offer text is the title of it, right? That's up here. That's the navigation title that is being set. And there's a toolbar with two buttons, right? First of all, just one button here. The second one is going to come on the next slide. So this has a button called credits. So we're wrapping this VStack into a navigation stack, right? We're embedding it into the navigation stack. And that's all you need to do to get this functionality, right? You put navigation stack around your content, and it becomes the starting point of a possible drill down navigation model. A couple of things that are of note here. The navigation title is actually, as you may notice, not being set in the navigation stack, but it's set inside the VStack. See, this modifier here, .navigation title, is actually part of VStack, not of the navigation stack. Any idea why that is the case? Why is the title that I'm displaying up there, which is the offer, why is that part of the VStack and not of the navigation stack? Yeah?
The navigation stack automatically sets its title depending on the context. So by doing that, you could sort of easily swap out the content, from the context, and the navigation stack would automatically update the title.
Right. So this is the current title that we want to see up there. But as we saw in our example, once we drill down into one of the destination pages, we want this to change, and it depends on the content that the navigation stack is currently training, not on the navigation stack itself. Right. Okay. So that's interesting. The toolbar actually can be anything, right? So the navigation title needs to be a simple text, but the toolbar can actually be anything. You could put any view in there that you want. We are using toolbar item here because that helps with alignment, right? We could have placed the button there directly, but if you use toolbar item, it helps you to get the alignment right, to put it where the navigation bar is trailing right at the end of this this navigation bar. If you want to add more items to this, you can do that with another toolbar item that has a navigation bar leading, for example. That's possible. So you would have one on the left and on the right. We often see that. But if you actually wanted to, this is about the fact that this navigation title gets added to the VStack. Yeah. But if you wanted to actually add two buttons, credits and help here, all the way on the right, so this is a group of two buttons, that is also possible by using what's called a toolbar item group. That's fairly specific already. Probably won't be using that a lot, but it's there if you need it. Now, what's more interesting is how do we actually get from our home screen to our target screens, or our destination screens, right, that we want to change to if the user pushes one of these buttons, right? So we're going to do this in two ways for illustrative purposes. The first target is very simple. We have a navigation link here, and that navigation link is basically this button, right? It looks like a normal button. It has a title, and it has a destination parameter, and that destination is a new view, positive answer view. That needs to be some other view that we define somewhere in a separate Swift file probably, and that we can jump to if the user hits that link button. The second example is a little more complex. Here we are showing that we can also not just give you a simple text to create this button here, but we can actually provide our own view that serves as the starting point to go to the target. And here it's an HTAG of a text and an emoji and with a particular size, and then a little bit of text. Right? So that's because we wanted to apply different font sizes here to these two. We've created an HTAG out of two objects. That means we've used sort of the slightly more complex way of declaring the navigation link. The rest hasn't changed. So let's take a look at the destinations. First, the simple destination that we're jumping to here, the positive answer view. It's very simple. It's a new view, right? It follows the view protocol. It's called positive answer view, obviously, because that's what we called it in the other file or in the other struct. And it has a computed body var that is just a VStack that says SwiftUI is awesome, and that's it. Right? So the only thing you notice here is, and that goes back to what you just said earlier, here in this stack, we're now swapping out, right, the content that the navigation view is showing, the navigation stack, sorry. And because we do that, we can now change the navigation title to say something else, right? It can now say the secret. Also notice something else. While the new title of this thing is now the secret, we automatically get this back button that says the offer. We didn't do anything for that, right? That is being derived by SwiftUI because the navigation stack knows that this is where you were coming from, and it knows the title of where you were coming from, so it automatically generates that back button for you. If you want to get a little more fancy, and that's what we do with our second destination, we can not display this automatically generated button up here, right? Because maybe we decide that's not the right way to navigate this because we want to have another way for the user to go back, like with this button down here. So if we do that, then what we need to provide is basically a way to return, which is this button that says, could you repeat what you just said? And the action that is being executed if you hit that button is presentation mode wrapped value dismiss. So this basically dismisses this screen and goes back to the last one. And that pops basically one item from the navigation stack. But what you also notice is we've hidden the back bar, the navigation bar back button here. We've given the title, again, like in the last one with, in this case, text, a missed opportunity. And we're doing something weird up here. There's this new add environment thing. What is this doing? Well, the add environment property wrapper reads something from a view's environment. So in this case, we're using this so that actually our current view, the button in our current view, is actually able to dismiss this scene from the environment and go back. Right? this fits the conversation style better, you could say, in this particular example, because we don't want the simple back button. But in order to do that, we need to get to this presentation mode. Right? So what we're doing is basically so that our button can actually dismiss this whole view. We enter the environment, we read what you could imagine as sort of a bunch of global variables and parameters that actually have paths. Like this is a path leading to this particular value, and we put this into a variable that we also call presentation mode, and then we can use that and do something with it, like for example dismissing the view. So as I said, add environment may come back to you occasionally. So we're pretty much there. We need to still consider how we can use sheets. You've often seen sheets that slide in from the bottom, for example, right? So a slightly different thing from your typical drill down and pop back up navigation style. Here's an example on how you would do that. This is actually different. Here we don't have a separate view we put into a separate view struct that we then only jump to, but we actually provide it right inside the body property. How do we do that? Well, there is a modifier called .sheet. It takes a Boolean variable, and if that variable is true, then it will show whatever you tell it to show, a view. But if it's false, it's not going to show. Right? And the button that you could press in your starting page could be called sure. And the moment you hit that button, you basically execute something. You basically toggle the Boolean variable show secret, which we have turned back to a state variable, because we're staying inside a view. We don't need a binding at this point, right? So when show secret then is toggled from false to true, at that moment, remember, the moment a variable like this changes, the views get notified that need to, that depend on this. So since we know that .sheet, or SwiftUI knows that .sheet depends on this variable, it will re-render itself, and it will show the positive answer view with that value passed in. Okay. And the moment the user would basically toggle that back, you would basically be back to where we were before. So this also shows passing this in basically as a you could do the same thing with a navigation link here that we just did. So that's another way of handling these things. And finally, if you wanted to see how this would be then your positive answer view that has the binding variable, because now we are at the target, and this is a different view, and all it would have to do, there's no more fiddling with the environment. It would basically just have to set show secret to false, because it's a binding variable, so that gets passed on out into the parent view, and then the parent view knows that this view is no longer visible. All right. Here's the last example for showing how you would end up with a whole bunch of navigation links. You can see here that we are able to specify destinations with a navigation link that has a particular value, and you can use that value in the navigation destination modifier to specify where you actually want to be going. Right? So here we're using a string value, but basically you could add more modifiers like navigation destination modifiers with different types. Depends on, you just need to give the navigation stack a navigation path parameter to do that. So this one basically is a view that has a bunch of names, and we're creating a navigation stack that starts out with a list as the home screen, right, of these people. And each person item that is being added to the list here is at the same time a navigation link, which you can think of as a button that takes you to a detailed view, right? And the destination is also provided with the profile page, which we assume is a separate view that we haven't seen here yet, that gets past this individual person. So this is pretty elegant if you look at it, right? Specifying a whole list with what kind of details you want to go to for each item in the list. This lets you do that. All right, now SwiftUI has tons of more stuff, right? But I want to wrap up and give you some pointers for further reading. So the SwiftUI tutorials from Apple and the WWDC presentations are your go-to source for like the ground truth about SwiftUI, right? The tutorials are really good for beginners. And the WWDC presentations are good if you want to catch the latest news and changes that happened. And they're pretty well presented and are the authoritative source. Secondly, there is Paul Haggardy's course at Stanford University that he's been teaching for many years, sort of in parallel to our own iOS class. And he's moved to SwiftUI in this class completely. So you can look at this material online. Unfortunately, it hasn't been really updated this year yet, so I haven't seen him doing a 22 course, but there is material from 21 that is mostly based on the 2020 material. So it's pretty up to date and is also, I think, quite appropriate for a university audience. Then Paul Hudson's stuff is a little bit more hands-on and quite detailed. It's a free resource to learn SwiftUI in 100 days. You can skip the first 15 days because that's Swift. You could enter there when he starts talking about SwiftUI, actually. He also has some really good books. For example, the stuff I talked about with MVVM was heavily based on what he has to say in this book on Swift design patterns on the topic. Then if you are into a sort of more like a picture book approach, Mark Merkins has an excellent, there's a free book on getting started with SwiftUI that he has available, and his more comprehensive work is SwiftUI View Mastery. It's a visual guide to SwiftUI where he shows you how things look and how you make them look that way. Very interesting alternative approach to learning this stuff, and a good reference too. And well, we're all waiting. We're all not with holding our breath, but we're waiting for Apple to update their actual develop in Swift books that you've used for the textbook in the UIKit part of this class. We're expecting them to move to SwiftUI, probably with the upcoming version already, maybe a little later. It's not clear yet. Currently, it's all, as you saw, it's all about UIKit. So, to wrap up, the big messages. I think I want to review these because hopefully you've now seen why I've said these things, right? So, declarative programming definitely has its advantages. We're going to still see object-oriented programming. Of course, it's not going to go away, but declarative has its advantages, especially when you're building large user interfaces. We've talked about MVVM, how it can help you tackle some of the issues that MVC has for declarative programming. You've seen that Swift can actually describe a UI in a way that you can read the code very easily and almost see the UI building in your head as you look at it. You've also seen that the editor and the visual editor and the code editor are basically just two sides of the same coin that edit the same code, the UI code, and that the best app languages, like I think as we've seen with Swift here, have to evolve together with the UI code, the UI toolkit and the IDE. And this is how you end up with really highly efficient environments. I think Visual Studio is another example of Microsoft that takes a similar approach where these things are really being married together quite closely. And finally, declarative programming also lets you simplify development across mobile and desktop because you specify more like what the end result is supposed to be, not how to get there step by step as you would maybe in object-oriented programming. And SwiftUI, whether you end up working with it or not, is definitely an interesting case study of a paradigm shift happening across a major operating system family. With that, I'm done. This also concludes the lecture part of this class. In the upcoming weeks, we're going to have seminar presentations. So I'm now going to pass on to Ollie and Renee to take care of you guys with a little bit of review for one or two groups, right, for their final presentations of the seminar. And the third part, of course, is going to be your awesome projects, right, of this class. I'm looking forward to seeing what you guys come up with. Thanks very much.
This content was provided by RWTH Aachen University.